Hello everyone, myself Manjushri Somashekar, and this presentation is done by myself and my teammate Mr. Vikrant Yadav. This presentation is about time series analysis of Bitcoin price. The data set of this assignment is gathered from coinmarketcap.com, which includes the daily closing price of Bitcoin from 27th of April 2013 to 3rd of March 2018. The main purpose of this assignment is to analyze the data by using time series analysis method and accurately predict the value of Bitcoin for the next 10 days. The first procedure was to read the data and convert to the TS objects. When we consider the time series plot of Bitcoin price, there are multiple trends in this series and a lot of periods volatility is quite high, and this implies in existence of arch effect. We can observe there are fluctuating successive points and succeeding observation implying moving average and also the autoregressive nature in the trend. But there is no strong obvious seasonality because at some parts it's very low and at few parts have very high trends in it. Observing the ACF and PACF of Bitcoin price series, the ACF has a slowly decaying pattern and the expected exponential decay in the ACF plot of this series. So the AR1 has autocorrelation lag of 1, 2 and 3 and so on. So there is a very high first correlation in PACF which implies the existence of trend and it is non-stationarity. Hence we will consider converting the series to a written series and apply Gauge model. We applied the log transformation to remove the non-stationarity, but the log of the series adjusts for change in variance, but the trend still exists. Hence, we applied the differencing of order 1 to log series to calculate the returns of Bitcoin price to remove the trend. But the return series shows lot of fluctuating points. Volatility is obvious. There is no sense of trend or seasonality and hence suggesting heteroscedasticity. Coming to the model specification, in ACF and PACF, it is not just white noise, but we have few very high significant lags in ACF. There is very high first correlation in PACF. Considering EACF, it is suggesting a zero model. Although there are some significant correlation in ACF and PACF, but EACF table supports ARMA model of 00. Due to this, we look at McLeod-Lee test. The McLeod-Lee test are highly significant and the normality assumption is highly violated. And the QQ normal plot has thick tails on both left and right side. So considering observation of both McLeod-Lee test and QQ normal plot, it indicates that it is a Arch-Gauge model. For this specification of the order of Gauge model, we are using squared and absolute value series of the returns. In this slide, we can observe both ACF, PACF and also EACF for both absolute values and square of Bitcoin series. We have a lot of significant correlation in both ACF and PACF with the effects of highly volatile series for both the squared and absolute value series. So the EACF gives a very clear picture of autocorrelation structure here. So the possible models are Gauge 1-1 model in which all the coefficients are significant. Normality is quite bad and has no problem with the autocorrelation. Gauge 1-2 model in which all the coefficients are significant. Normality is also quite bad and also has no problem with the autocorrelation. Gauge 2-2 model in which coefficients has 2 insignificance. Normality is also bad and has no problem with autocorrelation, but it seems like it is trying to overfit the data. Gauge 3-3 model in which coefficients has 3 insignificance. Normality is quite bad and has no problem with autocorrelation, but Gauge 3-3 model is also trying to overfit the data like Gauge 2-2 model. And when we observe AIC values for all the possible models, GACH11 has the low AIC value with the 9674.087 value, and also has all the coefficients which are significant, and hence we consider GACH11 model.
Following is the result of GACH11 model. Looking at the visual analysis of the here we have the result of here we can see the prediction made. The visualization of the model show the forecasted value when compared to here's the mean absolute scale.